Yes, my dear students, welcome back to today's session. We will continue the solution of the problem that we had started in the last session. In the last session, we had found out the moments at the ends of the members by slope-deflection method. These are the values: MAB 1.69 kilonewton meter, MBA minus 50, MBC plus 50, MCB 0. So in this session, we will see how to draw bending moment diagram and shear force diagram. Now if you look at MAB, it is plus 1.69. What is meaning of plus? It is anti-clockwise. Why it is anti-clockwise? Because our sign convention positive is anti-clockwise. And MBA minus means it is clockwise. And MBC anti-clockwise. So this is how we first identify the signs of the moments. Once you get the values positive anti-clockwise, negative clockwise, positive anti-clockwise. We'll go to the main structure and mark them anti-clockwise. I have already marked here. And MBA clockwise, MBC anti-clockwise, and MCB 0. So this is how I have marked. Now let us decide whether they are hogging or sagging moment. What is meaning of a hogging moment? A moment which is anti-clockwise on the left side of any member, it is called hogging. So this moment which is on the left side of AB, it is anti-clockwise, that is why it is hogging. So MAB is hogging. Now MBA on the right side of AB, it is clockwise. Again it is hogging. Both are hogging. This is anti-clockwise, this is clockwise, but both are hogging in nature. Now MBC anti-clockwise. Anti-clockwise for BC, this is left side. So again for left side, anti-clockwise hogging. That means all the three moments are hogging in nature. Hogging. So using these hogging moments, now we will draw the bending moment diagram. For drawing the bending moment diagram, the simple principle or the simple concept is first draw a horizontal line. Then consider AB as simply supported beam and draw the free bending moment diagram. What is meaning of free bending moment diagram? If you consider AB as simply supported beam, the bending moment diagram that is drawn is called free bending moment diagram. So this is where the concentrated load acts for simply supported beam. If you consider AB as simply supported beam, the diagram is triangle that has studied in strength of materials. What is this ordinate? This ordinate is WKB upon N. W is how much? 30. A 4. B 2 divided by 6. So if you do the calculation, it comes 40 kilonewton meter. So this is 40 kilonewton meter. How this is calculated? WAB upon N. Now what is free bending moment diagram for BC? BC means consider BC as simply supported beam. And when you consider simply supported beam, the bending moment diagram is a parabola. What is the ordinate? The ordinate is given by, you know the formula, standard, WL square upon 8. W is how much? 15. L square, this is 6 square divided by 8. This is the standard formula. So it comes to how much? 67.5 kilonewton meter. So this is free bending moment diagram. This is sagging, this is sagging. Now over this sagging free bending moment diagram, now we are going to superimpose these three values. So what is MAB? Hogging. So superimposition technique is over that, draw 1.69 kilonewton meter moment here. And moment at B is only one value. MBA and MBC together is only 50 hogging. So only one value, 50 hogging. 50 kilonewton meter hogging. And here it is 0. Now join this line and join this line. Here it is 0. So moment here is 1.69 kilonewton meter hogging at A. Moment at B is 50 kilonewton meter hogging. Moment at C is 0. And now the remaining diagram, this is the shaded portion or hatched portion, is the net bending moment diagram. That means this much bending moment diagram has cancelled. That means over sagging bending moment diagram, we have superimposed the hogging values. The hogging values are these. So the net bending moment diagram is a diagram which is shown by the shaded portion. So this is your final BMD. That's all. So this principle is called principle of superimposition. That means over the So this is how we draw the merhod diagram, and we are going to continue with this principle for all the modules of analysis of indeterminate structure. Is that clear? Okay. Now having done this, now let us draw the shear force diagram. How to draw the shear force diagram? So my dear students, you know that to draw the shear force diagrams, what you need? You need reactions. So let us first find out the reactions. Now, there is a principle or technique of finding the reactions. How to find the reactions? First, what we need to do is, we have to find out reactions due to simply supported condition, or simply I call them as free reaction. So consider BMD as simply supported beam. What is this each reaction? This reaction and this reaction. This reaction is given by WB by L. W is 30. B is 2 divided by 6. And this is WA upon L. 30 into 4 divided by 6. These are free reactions. And what are the free reactions for these two supports? When UDL is there, WL by 2. W is 15. L is how much? 6. Again, this is 6 meters. Divided by 2. 15 into 6 divided by 2. Directly you should be able to write. So these free reactions are 30 into 2, 60. Divided by 6 is 10 kilonewton. And here it is 30 into 4 divided by 6, it becomes 20 kilonewton. You can do the calculations, and it is 15 into 6 divided by 2. So each free reaction will be 45 and 45. So these are the free reactions. You understand? So first step is to find out the free reactions. Once we find out the free reactions, now we will see the reactions due to moments. How many moments are there? 1, 2 and 3. Look at this span AB. There are 2 moments. One is anti-clockwise, one is clockwise. So what is the net moment here? Net moment is the difference of these 2 moments. The moment here is 1.69, the moment here is 50. 1.69 is anti-clockwise and this is 50. So the net moment is 50 minus 1.69, because 50 is bigger, 1.69 is smaller. So the value, it becomes 50 minus 1.69. How much it becomes? 50 minus 1.69, you can directly write 48.33. 48.33 kilonewton meter. Now, the moment here is how much? Only 50 and 0 here. So it is anti-clockwise 50 kilonewton meter. So these are moments. They are called unbalanced moments. So these unbalanced moments are to be balanced. How they are to be balanced? 48.23 anti-clockwise moment is acting. Clockwise moment is acting. So the reactions should be such that they should be able to produce an anti-clockwise couple to balance this. And this couple is given by moment divided by span. Moment is how much? 48.33 unbalanced divided by span is 6 meters. So this is also 48.33 divided by 6. Now come to this span. What is the unbalanced moment left? 50. It is anti-clockwise. So you need to give clockwise to balance this against this. That is 50 divided by 6 is each reaction. 50 by 6, 50 by 6. So the reactions are 48.33 upon 6 acting downwards, 48.33 upon 6 acting upwards, 50 by 6 acting upward, 50 by 6 acting downwards. These are the reactions due to moments. Unbalanced moment, or simply reactions due to moments. Now what we will do is we will sum up the all reactions. This is how much? 10 minus this, 20 plus 45 plus then 45 minus. So when I do this, I am going to get the final reactions that I have already calculated. I will just write down here 1.945 kilonewton, and here it is 81.388, and then this is the final reaction here. 45 minus 50 by 6, that comes to 8.33. Sorry, not 36.667. 36.667. So these are the values. How we have found out, I will explain once again, because this is a very important step to find out the shear force diagram. What I have done, I will explain once again. Please note down. Here, first we are finding the free reactions. What are free reactions? Considering each beam is simply supported, we have found out free reaction. What is this reaction? WB upon L. This is WA upon L. That is 10, and this is 20. And this is, each free reaction is WL by 2. WL divided by 2, that is 45. WL divided by 2, 45. So these are the reactions. They are called 10, 20, 45, 45. They are free reactions. Now the moments, the unbalanced moment. The difference of these two is how much? It is moment is 1.6 times here. The moment is 50. So 50 minus 1.6 times 48.33 clockwise, because the clockwise is more, anti-clockwise is less. So 48.33 clockwise. Now here 50 and 0. So it is unbalanced moment is 50 anti-clockwise. So the unbalanced moment are 48.33 for AB and 50 for BC. Now finally, now these are the unbalanced moments. So they need to be balanced. That is why they are called unbalanced moment. That is why what we do is we give the reverse moment. What is reverse moment? Moment divided by span is each reaction. So moment is 48.33 divided by span 6. It is acting clockwise. So the moment, the reaction should be such that here it should be up, it should be down. It can create an anti-clockwise couple. So this anti-clockwise couple will balance with this moment. That is why each reaction is 48.33 by 6, 48.33 by 6. Come to the span BC. Unbalanced moment is anti-clockwise. So you need to give clockwise. Clockwise means the reaction here should be up, down. So you can see it is producing a clockwise couple. So each reaction is equal to moment divided by span. 50 by 6, 50 by 6. So you add this. What you have to add? 10 and this. 10 is acting upward, 48.33 is acting downward. So algebraic sum. It comes to 1.945. Now come here, add this plus 20 plus 45 plus 48.33 upon 6 plus 50 by 6, it becomes 81.388. Then plus 45 minus 50 by 6 plus 36.667. So these are the three reactions. Now you add all the three reactions, it should be equal to the total load. What is the total load? 30 plus 15 into 6. How much is 15 into 6? 90. 90 plus 30, 120. If you add, you must get 120. You will get it. Okay, having done this, now we have to draw shear force diagram. The shear force diagram concept is similar to the one we had studied in strength of material. So first I will draw a horizontal line. This is A, this is B, and this is C. These are the ends of the members. Let us draw the shear force diagram. Very interesting. Start with 1.945. Positive on the left side. Sign convention is on the left side. Shear force is positive. 1.945. Acting upward. Then there is no load in between here, so it remains constant up to this point where the load is acting. So 1.945 minus 30. Sudden there will be drop. So 1.945 minus 30, the value becomes minus 28.055. Minus 28.055. Minus 28.055. Then it remains constant. Then there is again sudden reaction of 81.33. Minus 28.055 plus 81.388. It becomes 52.33. This big value 52.33, and after 52.33 there is UDL, so there will be gradual drop at the rate of 15 per meter. So the total drop is 15 into 6. So plus 52.33 minus 15 into 6, that is 15 into 6 is 90. So minus 90. It becomes how much? The value becomes 36.667. 36.667, and then join this because it is UDL, so the shear force varies linearly. When there is concentrated load, shear force remains constant. When there is UDL, the shear force varies linearly. So plus 52.33, it drops at the rate of 15 per meter. So by the time it comes to C point, what is the total drop? 15 into 6, 90. So minus 90. So plus 52.33 minus 90 is minus 36.667. Then minus 36.667 plus 36.667, it comes here and becomes 0. So this is your shear force diagram. I hope you have understood the meaning or the concept of drawing the shear force diagram. So look here, once again I will explain because this is very important. Starts with 1.945 positive, remains constant up to 30. Sudden drop of minus 30, 1.945 minus 30 minus 28.055 remains constant. Sudden increase of 81.388. It becomes 52.33, then gradual drop of 15 into 6, that is total drop is 90. So 52.33 minus 90, it becomes minus 36.667, minus 36.667 plus 36.667, it closes here or becomes 0. This is what is your shear force diagram. I hope you have understood the concept of drawing shear force diagram and bending moment diagram because they are very different concepts. We are studying it for the first time. Bending moment diagram concept is superimposition concept. Shear force diagram concept is first we need to find out the reactions. How we have found out the reactions? We have split the reactions into two categories. First, free reactions or reactions due to simply supported conditions. Then the reactions due to unbalanced moments. Then add them as a diagram to get the final reactions. Once you know the final reactions, you simply apply the concept of shear force at each and every point and complete your shear force diagram. This is how it looks. Is it right, my dear students? I hope you have understood this, and I will come back to the next session in our next video. And if you have any doubts, let me know.